In this video I'm going to talk to you about the basics of what a chemical equation means. You should remember from GCSE you have reactants and you have products. Hopefully from the work you've already completed you also know that you can't change the formula within a chemical equation. Metals always appear on their own. This is a covalent compound, hydrochloric acid or HCl. It will always be one H bonded to one chlorine. Magnesium chloride is an ionic compound. Every Mg2 plus ion will bond with two Cl minus 2 chloride single minus chloride ions, and hydrogen is a covalent molecule. Each hydrogen only makes one bond to another hydrogen atom. If you're not sure about any of that, if you can't remember anything about it, go back over metallic, covalent and ionic bonding. Make sure you know how to write the formulas for all the different types of substances and why they have those formulas. So what we'll assume is that you're happy to accept the little numbers in a formula cannot change. What does the rest of the equation mean? What it should do is tell you the exact ratios of the substances that react with each other. This one doesn't, it's not balanced. So balanced means that the exact number of atoms that appear on the left rearrange in some way and also appear on the right. Now you can see for the magnesium it works. I have one magnesium on the left, one magnesium on the right. It's great. With the hydrogen though, there's one hydrogen atom on the left and only two hydrogen atoms on the right. The same with the chlorine. What it's tempting to do is fix it by changing the formula of hydrogen chloride. You can't do that. That doesn't exist. That's not what hydrogen chloride is. So this is where we put large numbers in front, big numbers you might have called them at GCSE. They're properly termed stoichiometric coefficients. This is quite simple. It should be quite easy to see that we put a large 2 in front of the hydrogen chloride. Now what that actually means is that you have one magnesium atom that will react with two hydrogen chlorides. The products will be magnesium chloride, which is Mg2+, with its two singly charged chloride ions, and a molecule of hydrogen. You can see by simple counting now, two hydrogens, two hydrogens, two chlorines, one Mg, one Mg. It works. So that's a balanced equation. It doesn't seem that important, but all of the calculations that you'll be doing further on in chemistry require you to be able to balance an equation and understand what that means. So let's move on to that start of that stage now. So you can think of the big numbers talking about specific molecules. So we've got one magnesium, two HCl's, one MgCl2 and one H2. What we also need to do is actually develop our understanding of this and think of it in terms of counting moles. Remember, moles are what chemists use to count large numbers of atoms or molecules. So, the ratio of the moles for this equation is one magnesium to two HCl's to one MgCl2 to one H2. So that's 1 to 2 to 1 to 1. So if I have 1 mole of magnesium, I will need to react it with 2 moles of HCl. It will produce 1 mole of magnesium chloride and 1 mole of hydrogen. This sometimes makes people panic because they look at it and go, well, how can 3 things become 2 things? Remember, if you look back at the actual a bit more information about the structure and the formula of the substances, although you're taking 1, 2, 3 things and only making 2, the atoms have moved themselves around, rebonded with different substances in a way that makes that possible. So, why is this important? Often you won't be dealing with nice and easy, neat round numbers. You might have a situation, for example, where you start off, you have only half a mole of magnesium. In that case, how much hydrogen HCl will I actually need to react with it? Well, if the ratio is 1 to 2, if I had 1 mole, I need 2 moles, so I need twice as much. I'll start off with half a mole, so I need 1 mole of HCl in this case, still the 1:2 ratio. If I look at the products to work out how much is produced, keep it all in relation to the mg. So the ratio of mg to mgCl2 is 1:1. If I started off with half, I'm going to get half a mole of mgCl2. I'm also going to get half a mole of H2. These are still quite nice, easy numbers. Let's talk about 10 moles of magnesium. If the ratio is 1:2 to 1:1, you can predict before I say what the ratio of what the amounts of the substances are. I'll need 20 moles of HCl. It will produce 10 moles of magnesium chloride and 10 moles of hydrogen. Could we do it if it's weird, strange quantities? 0.241 moles. More often than that, you will be actually dealing with smaller numbers to obviously express the 3 significant figures. If the ratio is 1:2, all we're doing is doubling that. And every time these others stay the same. So let's use the same technique. If I double 10 to get 20, double 1 to get 2, I'm just going to double 0.241 to get 0.482. If this was an exam or if I was under pressure, I'd do it on my calculator. The others are just going to be the same as the amount of moles of magnesium. 0.241, 0.241. Hopefully this little recap has helped. What I'd like you to do now is go and try task 9, which is more practice doing these molar ratios with different equations. Good luck, see me if you need any help.